All right, in this video, we're going to look at finding the sum of an infinite geometric series. So in our last video, we looked at the formula for a finite geometric series given here, where a1 is our first term. And it works for a finite or limited number of terms, but what happens if we want to add up an unlimited or infinite number of terms? And we're going to be able to find a sum for infinite series infinite geometric series, let me put that stipulation in there, on the condition that our common ratio, the absolute value of it, is less than 1. Or to put it another way, our common ratio is between -1 and 1, not including those end values. And the reason for that is because as we add more and more terms to our geometric series, if our common ratio, let's say, is bigger than 1, let's say it's 5, that means each new term is 5 times what the previous value was. So if we keep adding larger and larger and larger numbers, our series, our total, our sum is never going to approach an actual value. It's just going to keep getting larger, larger, larger. However, by making our common ratio between -1 and 1, that'll guarantee that our terms that we're adding are getting less and less and less as far as a geometric series are concerned, and we actually will have a sum for infinite geometric series under that condition. So our sum for an infinite geometric series, notice with this formula, the 1 minus r to the n is gone. So it's just our first term divided by 1 minus our ratio. So it's even easier than the finite ones. So an infinite series that actually has a sum that we can find is said to converge, which will happen for these infinite geometric series if our common ratio is between -1 and 1, not inclusive. A series that does not converge is said to diverge. So if it doesn't converge, it diverges. All right, example 6, find the sum of each infinite series. So we have 3/8 minus 3/16 plus 3 over 32 minus 3 over 64, yada, yada, yada. So first up, what we want to do is find our common ratio. It has to pass that test for a sum to happen and to converge to a value. So if we take let's say our second term divided by our first term, -3/16 divided by 3/8 is -1/2. And -1/2 is between -1 and 1, so this will actually converge to a value. So now we take our first term, which is 3/8, and divide it by 1 minus our common ratio of -1/2. So we just put this into our calculator, we end up with 1/4. So adding an infinite number of terms in this geometric series will actually give us a value of 1/4. Part B, once again, we have 3 plus 2 plus 4/3 plus 8/9. We have a common ratio here of 2/3, which is really easy if you use the first and second term. And 2/3 is between -1 and 1, so we will get a sum for this series that converges. To find that sum, we're going to take our first term, which is 3, divided by 1 minus our common ratio of 2/3, and we get 9. So adding up an infinite number of terms in that geometric series will give us a finite number here of 9. Part C, -3.6 times 0.6 to the I minus 1 power from I equals 1 to infinity. So here we have a series written using sigma notation, which when you get into upper level math, especially in either Calc 2 or BC Calc, you'll see your infinite series written in this form. So to get our common ratio, we need to look at the base of our exponential function here, which is 0.6. And 0.6 is between -1 and 1, so this will actually converge to a value. To get that value, we need to find the first term by plugging in our lower limit of summation into our expression. So -3.6 times 0.6 to the 1 minus 1 power gives us a value of -3.6. So we take that first term of -3.6 divided by 1 minus our common ratio of 0.6, and we get -9. Part D, from 1 to infinity of 2 to the 1/3 to the, or 2 times 1/3 to the n minus 1 power. So our common ratio here is 1/3, it's the base of our exponential function, and it is between -1 and 1, so it will converge to a value. The first term, plug in the lower limit of 1 into the sequence rule here. So 2 times 1/3 to the 1 minus 1 power gives us 2. Take that first term of 2, divide it by 1 minus our common ratio of 1/3, and let the calculator do what it's good at, and we get 3. All right, part E, we have 4/3 to the I power from I equals 1 to infinity. Our common ratio here is 4/3, which unfortunately is not between -1 and 1. So we keep adding larger and larger numbers each time, which means our series is going to diverge. So we can't find a sum. Now, if you did find a sum for this, let's say if you didn't bother checking this condition here, that 4/3 is between -1 and 1, what you would get for your first term is 4/3. Your common ratio is also 4/3. So if you attempted to solve this problem using the formula, you get 4/3 over 1 minus 4/3, which is 4/3 over -1/3, which equals -4. Now, if you think about it, how can you add up a bunch of positive numbers here and end up with a -4 as your answer? And the answer is that you can't do that, which means there's a mistake in that calculation, and the mistake is that 4/3 is not between -1 and 1. So always make sure you check that common ratio value first before you just go and plug them into a formula. Part F, we have 0.1 times -2.5 to the I power from I equals 1 to infinity. Our common ratio here is -2.5, which is not between -1 and 1. So this too will diverge as well. So, all right, that about does it for this video. Thanks for watching. I'll see you next time.